Hi, everyone. Here we're going to be talking about exploratory data analysis part 2, and we're focusing more now on quantitative variables. And we'll talk about distributions, histograms, density plots, shapes of distributions, percentiles, tools for statistical analyses, and measures of central tendency. And also some of this content is coming from the textbook that we're borrowing, Montana State Introductory Statistics textbook. Distributions, the variables of repeated instances or repeated events. Let's remember that statistics is about repeated events. It's not about a case study. It's not about n equals 1. It's usually about multiple instances. So in a general sense, every sample, just the sample itself, is a distribution. It refers to multiple instances, and it has that category, this characteristic has a value, and that is what we call n. The instances or records of a data set is referred to as n. In this case of the example here, n equals 1,174. And this is the most basic fact of a sample or data set. Usually the higher the n, the better. It's more generalizable and representative of the population we're interested in. But in some cases, it can also create complications for the tests we do. So that's the most important, or the first basic fact about a sample, the sample size. But of course, samples have characteristics. We're not just cared about a sample with no variable that we're measuring. So we usually discuss distribution of a variable, and distribution of a variable is a description of the possible values a variable takes and how frequently each value or set of values occurs. So something like distribution of shares of the tweets that we have exemplified here, or of the likes, and so on. It's focused on a particular variable. Distributions of categorical data are called frequency distributions or frequency tables, and we've already talked about them. So for example, in the set of tweets that I have here, we can talk about the count of agencies. So there's 61 tweets from NIH, 45 from CDC, and so on. So the frequency has to do with the counts of the records themselves. So there's 61 records, 45 records out of the total 1,174 records. Now, when we're focused on a histogram, when we're focused on a quantitative distribution, we use the histogram to graph the frequency of that quantitative attribute. And that is a graph separated into bins or ranges. So let's take a look at an example here. So we're focused on this data set of tweets. Each record is a tweet. Each row, here's a tweet. And the variable here, the shares variable, also called the retweet count, is over here. And these are integers. So you can see the first one is 12, and the next one is 0, the next one is 0, then 0, and another one has 3 tweets, and another one has only one. Retweets, and another one has only one retweet. Once again, just another word for share. And when we create a histogram of this variable, of this data set, it's going to look something like this. So how do we read this? Well, in a histogram, on the y-axis is the frequency. Frequency goes on the y-axis, and the values of the variable go on the x-axis. So for example, let's begin on bin 2 here. Between instances that had the values between 10 and 20 made up 40, not 40%, just 40 records. 40 records, about 40 records had values between 10 and 20. About 10 or so records had values between 20 and 30. About 18 or so records, how can I tell 18? Because I see 20 here, I'm just estimating. About 18 or so records had values between 120. Value of what? Once again, we're talking about shares. So only 18% of the whole, not 18%, 18 records, only 18 instances, only 18 tweets had shares greater than 120. And about 200 which is actually not 200 because I cut the graph. This goes all the way here to 1,000. So the vast, or 800 or something. So the vast majority of tweets, of messages, only have between 0 and 10 shares. So this is what we call a highly skewed graph with a long tail. And we'll talk more about this in these lectures. So here's just another example, histogram of interest rate from the textbook we are using. Frequency on the y-axis, and whatever value, variable of interest, in this case, interest rate, are here. And notice how it's in bins as well. These are not clearly named, but this may be between 5 and 7.5, 7.5 and 10. I'm just kind of inferencing here because of the distance, 10 and 12.5, between 15 and so on. Also, histograms can be transformed into density plots. So a histogram is a kind of data density, right? So we see here that a lot of the frequency, for example, for interest rates seem to be between 5 and 10%, unless there's very few frequency of interest rates at between 20 and 25%. So it's a kind of data density. What can also be generated by mathematical calculations and computer functions is a density plot, which is a smoothed out histogram that actually transforms the data from frequency counts to proportions. And the density proportion becomes the y-axis. So here becomes the density or the proportion. And so instead of just the hard frequency itself, and then we still keep the same variable on the x-axis. So we can see that, for example, about 10%, interest rates of 10% actually make up 10% of the data. Interest rates of about 5% make up about 5% of the data. Interest rates of about 20% make up about 2.5% of the data, and so on. Okay, that's it for this one. We'll continue next time.